Hi everybody, it's crazy, it's Monday, and it's time for the UPBGE video of the week. Now, before I get started, gotta give a shout out to my trusted crew. You guys rock. To my crazy fam, I love you guys. Now, we're up to episode number 108, and last week we left off with, let's see if I can do it right from the get-go. We left off with vehicle physics, and left off on page 37, and we left off with the file of constraints, because that was the last one we did. And if you hit, let me get my cursor over here, if you hit P, you'll watch that the hinge moves and the ball joint kind of does its thing, the cone twist does its thing, and the slider does its thing. Okay, so that was constraints. Now what we're going to do is something completely different today. We're doing vehicle physics, so let's get started. So vehicle physics. The Blender physics engine has built-in support for vehicle physics. It is a very stable physics constraint system that provides easy to set up car physics. The result is a fast-performing vehicle physics engine with easily tweakable settings that maps well into a real vehicle, which is steering, suspension length, and suspension stiffness. Of course, you can also try to create a car physics setup without using the built-in physics constraints. However, it will be far more time consuming because you got to write your own scripts. Okay, this section will demonstrate how to set up a playable car object in the game engine using the built-in bullet engine and a bit of scripting, Python scripting, excuse me. Hands-on tutorial. Let's say that 5 times fast. Vehicle physics using Python. To get started, open book chapter 6, vehicle and car.blend. So you got to come over here and go to file, open. Okay, you're going to go back to where you get to chapter 6 because right now we're in a demo. Okay, you're going to go to vehicle physics and then go to car.blend. Okay, again, you're going to go back to chapter 6 and you're going to go into vehicle and you're going to hit car.blend. I've already got it opened up here, so let me go ahead and just move that out of the way. And as you see, you got your nice little car right here. Okay, all that neat stuff. All right, so you'll notice that you won't see this on your file. That's okay because we're going to add that in. It's just mainly they wanted to show you where each wheel is. Okay, so let's get started with that. Rather than presenting this as a step-by-step tutorial, we will dissect a fully working pre-made file. Our basic car is composed of a body object, which is this little guy right here, and 4 wheel objects, which are these 4 guys right there. Okay, the wheels are separate from the car for now, so if I hit grab and Z, you'll notice that, oh my god, the wheels are not hooked to the car. Okay, the physics engine will be responsible for keeping the wheels attached to the body, so the location of the wheel objects does not matter at this point. In this file, they are placed close to the car body for convenience. Because attaching the wheels to the body will be done by a script, it is crucial for the rotation of the wheel to be correctly set. Otherwise, the wheel will be linked to the car in the wrong orientation once the physics engine takes over. In the sample file, notice that the wheel objects all have their rotation set to 0, 0, 0, which is this right here. This is your rotation. If you hit your N on your keyboard, okay, it will bring that up. And at the very top of it, you will see your location, your rotation, and your scale, and your dimensions. Okay, you want rotation set to 0, okay? This is important because the local rotation on the objects will interfere with the physics engine and confuse the game engine, resulting in unexpected behavior when you try to attach the wheels to the car. If a wheel needs to have its rotation reset, press Control A, okay, and apply any rotation. So you're going to come down here and click rotation on your wheels only. Don't do it on your body. Okay. But you want to make sure that each wheel is set to 0, 0, and 0. Okay? All right. Also notice the car body is a rigid body, okay, object with the ghost turned on. This setting is crucial for the car physics to run correctly. So you need to have ghost and you need to have it as rigid body. You cannot put it as a soft body, and you cannot do it without ghost without having problems happen. Okay? That's pretty much it. A car body object and 4 tires makes up the vehicle. As already mentioned, the actual vehicle physics relies on some Python script to function. Okay? And as you see below, right here, okay, all the logic bricks that are attached to the car body object, notice that the script plays a big part in it. Okay? So these weren't here. I put them in. From the book itself, it shows these, but your file will not. The reason why is because they left them off. It's not really a functioning deal. They just wanted to show you what it was about. Okay. Now I'm going to go over here and I'm going to open one. Oops. Okay, don't have it in there. I have to add one. Go to a file. Okay, as you see, if you go into your game, files, chapter 6, and then vehicles, you'll see that there is a script PY. I'm going to open it up so we can see it in here, because we want to be able to read it and follow along with it, okay? It's a lot easier to deal with. All right, so the script car.init, okay, which is car init, okay? If you look over here, you will find the car init, define car init, which is a Python term for define, okay? And this is all the stuff for the car's initialization, okay? And I'm gonna read on to that, okay? Is run when the game is started. Here, it initializes the car as a vehicle constraint, also known as constraint type 11, and stores it as a Python object called vehicle. Okay, so it's going to store it as a vehicle. Okay. The same script then looks for the 4 wheels by accessing an actuator with specific names. In this case, wheel 1, wheel 2, and etc. It's going to have to find each wheel. Okay, and then it defines them. And then the script attaches the wheels to the car body using the settings specified in the script, which is right here. Okay. Variables such as roll influence, suspension stiffness, and tire friction can also be set on a per tire basis once the vehicle object is created. Okay. So you can deal with all of this with friction and everything. Okay. For each individual tire. All right. The job of car init is now done. Okay, so we just did car init. Okay, your car body is now considered to be a vehicle by the game engine, and it will behave like one. The second most important function, script.carHandler, is run every frame. Okay, as you see by the always. If it hasn't always, it's done every frame. Okay. This script does the actual moving of the car, and it applies engine force and steering to the vehicle object. But this script gets the user input, keyboard sensor inputs, from another source. We're going to see that below. I'm going to read that below. Okay. The vehicle wrapper has built-in methods such as apply braking, apply engine force, and get wheel rotation, and get number wheels, which you can call. Okay, so that's this right here, down here. We're going to go to key handler after that. But this gets all of that information and it sets it up, ready to go. Okay? All right, so every time a key is pressed, script.keyHandler, that's this one right here, every time a key is set, key handler picks up, okay, which is this script right here, and it tells you what key is hit. If that key is hit, you're going to do different things for it. Okay? All right. It figures out which key is pressed and sets the intermediate variable so that the script's car.handler function will know how much throttle to apply, which way to steer, and so on. This script is separated from scripts.carHandler not because of technical limitations by design, no, not because of limitations, but by design, so that it is easier to manage the code. Because if you try to put all that together, you'll have this long bit of code and it'll be a pain in the butt. Trust me, I know. With these 3 Python functions, that the car comes alive. Okay, so now you should be able to run this car. I found out that I tried it, I hit play, and I couldn't get it to do anything. Oh, there goes the wheels. Okay, as you see, you can now drive the car. Whee! dee as the car takes off screen, and you'll never see it again. Okay, so it does work. I guess I was pressing W, S, A, and D, but if you look up here where it shows the keys, it's up, down arrows and left, right arrows. So that is what it's supposed to use. So I didn't use that. So make sure you put these in here, because those right there are its visibility to see the wheels. If you don't have them in there, the car in it will not find it. Okay. So with that saying, we just did vehicle physics. You now have a working car. I'm going to continue on. I know this is going to be a little bit of a long video. I'm past my 10-minute mark, but I'm going to go ahead and try to finish this chapter, because I've only got say just a few more left, because we're at page 39 and all we got is 42 left. So I'm going to go ahead and finish that and end it off, and you just got game settings we're going to work with. Okay, so we're going to continue on with that. Let's see. Oops. There we go. Okay, so we're going to continue on with game settings. All right, and we'll go from there. Okay, game settings are global settings that affect the running of the game. These settings are shown in figure 629 and can be found in the render panel. Okay, these are going to be different, and I'm going to kick back over to here because you're about to see that. Okay, as I bring the render panel back up. Let's squish this down. Okay, the render panel is completely different from how it used to be, because a BGE now has it to where you have your embedded player and your standalone player, and a lot of things have changed around. So when it shows system, it shows your frame rate, but you don't have the display list, which no longer has, okay, because it doesn't need it. Restrict animation up does not have, but it has depreciation warnings, VSync, so on and so forth, and it has the exit key, which is exit, okay, or escape. You also, we don't need attachments because we're not attaching anything, okay. Also right below that is supposed to be display, but you also have your animation frame rate and restrict animation frame rate right here instead of here, instead of all in one. They had separated it out. Okay, your display has your mouse cursor, okay, which is by itself, and then it goes into debug, and which are all separate, because a lot of times you don't want to have your same debug properties stuck with your display. You know, they separated it out so that way you can minimize it down and do other stuff. Okay, but it also gives you your frame rate, your debug properties, so on and so forth. So your debug properties are these right here. Okay, so I'm gonna go over each one, and it's not really that much to go with, so I'm just gonna read them off. Okay, animation playback speed, closely related to the frame rate setting, is the animation playback speed. This setting controls the speed of the F curve and armature animation. By default, the value is set to 24. Okay, so if you come up here to the animation frame rate, this one is set to 25 because that's a little bit better. Okay, meaning all F curve and actions will be played back as if they were running at a 24 FPS time base. And they set it to 25. I don't know why, but that's just the way it is. This setting can be found in the render panel, which is the render panel. Okay, debug properties. That's this right here. It's not one specific little click box. Shows the value of the game properties that are marked with the debug flag. This can be useful when you want to keep an eye on the value of certain variables while the game is running. Your frame rate, your render queries, your properties, and your physics visualizations, and other things that can actually help you out. Okay, frame rate and profile shows the frame rate and other performance statistics in the game. These statistics will be displayed in the top left corner of the screen in the game. That's all these right here. Physics visualization, okay, which is this little guy right here, visualizes the internal computation of the physics engine. This can help you see what the physics engine is really doing when the game is running. Rigid body objects are displayed in white, and sleeping objects are drawn in green. Okay. Depreciation warning gives warnings about outdated Python API called in the console. See chapter 7. We'll get to that some other time. Mouse cursor draws the mouse cursor in game. This is useful if the game uses mouse input. Mouse cursor can also be turned on and off via Python. Okay, so you can also do that in here as well. You can turn this on in the game, and you'll be able to see your mouse cursor in game instead of just, you can make your own and you can have it do that Python. Okay? Stabilizing physics. The bullet physics engine is good, really good. But as with anything that is powered by a computer, it is still possible to get into a situation where things go awry or haywire. Okay, so what is unstable physics anyway? When you see objects jitter around when they are not supposed to, or when objects go through each other when they are supposed to collide, you know it's time for a reality check. Here are some tips to help you regain control of your game. All the settings here are already covered in the chapter. This list is simply a collection of the most common actions to take to stabilize physics. Avoid extremes. Avoid interaction between an extremely heavy object and an exceptionally light object. Avoid interaction between extremely fast objects. Avoid interaction between objects of very different sizes, especially if neither object is static. Physics substeps. World Properties Editor. Okay, that's talking about this deal here. It's also talking about this deal here. Crank it. Higher will be slower, but gives much more accurate physics simulation results. So the higher you put your, what was it? We did this already. The higher you put your value, the better it will be for your physics engine. Okay. Bounding box, physics properties editor. Okay, so they're talking about down here, and this is your bounding box, your bounds. Okay, you will want to put it as a box. Okay, or a bounding box. I've never seen that one, but yeah, box means box. Okay, try to use collision primitives: sphere, cube, cylinder. Okay, so use sphere, cube, where's cube? Yeah, cube and cylinder. Okay, so mainly those three. Rather than mesh-based collision boxes, triangular mesh or convex hull, the former will be more stable and perform faster. Okay, because you don't really need to have super physics, because you're not gonna, like, for example, this little car right here, every little inch will be covered if you have that physics type. As you see this outline, that right there is they just did a cube box. If I did that as triangular mesh, you'll notice that it disappears here because it's covering every part of this at every little angle, which would be not so good for your game. Okay, so you want to keep it as box or triangular. You can do sphere, which would make it kind of weird, or you can do cylinder, and stretch it out to where it would work. But most of the time, box works just fine because you're really not trying to do something, different. You don't really care if every little thing in here gets bumped. You just want it to hit it and come off. Okay. Let's see. Form factor. Physics property editor, which is here. Okay. Controls the rotation. Yeah. Rotational tendency of an object. Setting this too small will make moving objects extremely unstable. Increasing form factor usually helps calm down the object at the cost of making the object feel sluggish on collision. Okay, so that's this right here, your form factor. If you change, you want to have this a little higher if you notice things going awry. Okay, no sleeping. Okay, so turn on no sleeping. By default, this option is off, meaning objects freeze when their movement falls below a certain threshold for a certain time. Keeping the option off improves physics stability and performance. Okay, so if you turn this off, it will help. At least that's what it's saying. No. You want to have that on, because if not, it'll freeze and it'll cause problems. Keep the option off improves physics stability and performance. If you turn it off, it improves it, but you sacrifice a little bit. Okay. Object dampening. Physics properties editor. Okay. Object dampening is I know it's in here. No, they don't have it in here. I don't see it. But anyway, that's one of them. I just gotta find it. If you find it, cool. Okay, object dampening. For non-static objects, traditionally dampening and rotational dampening can be used to slow objects down. Setting this to a non-zero value ensures that objects eventually slow down to a stop, which might help with stability. And last but not least, margins. Okay, and I don't know where margins is in this either, so yeah. If you find it, cool. If you can't, oh well. Okay, a lot of these can be outdated, as you've seen from some of the files and some of the setups in here. If objects go through each other when they are not supposed to, and you've exhausted the other options listed above, increasing the object collision margin might help. Okay, so let's see, object collision margin. That one is actually a good one if you're looking at that. That's dampening. That's linear velocity, friction, mass, radius, form factor, elasticity. See from normal field. Nope. Okay, I guess it's not on a rigid body. Oh, no, right here. Your margin right here. Okay, so your margin, if you bring this up, the farther you bring this up, the more that collision box will get bigger. Okay, so make sure that, you know, if you want it to not, if you don't want objects to go through your object, then you want to create that margin a little bit bigger. Okay, that's about it. And that brings us to the end of chapter 6. Okay, so next week we're going to start on chapter 7, and we're going to start a whole new world. So stay tuned to that. Let me kick over to, hang on, let's kick that and that. Okay, so end of chapter 6. Next week we start chapter 7, and we'll start a whole new chapter. Let's see what that one is, just for giggles here. Let me find my folder. Let's bring that over here. Oh, I need to open up a new one. Let's see. I'm gonna go to the PDFs. I'm sorry, y'all. Okay, so next week we're going to be doing chapter 7, which is scripting. Oh, yay, that's going to be fun. If you're interested in learning a little bit about Python, you can also check one of my other series of videos, which should be somewhere, I think it's that way. Yeah. That way. Okay, you should see it on the bottom of the screen off to your left. The top one is the one we're doing now. You can learn a little bit more about Python as I was learning it a while back. I've forgotten a lot about it since, so going into scripting is going to be a little bit fun for me. So stay tuned until next week.